Hi, kids. All right. We're gonna do a two-body problem, another Newton's law dynamic problem. I have two bodies, hence it's a two-body problem. They are connected by a string, so they will be moving together. This one is 40 kilograms. This one's 20 kilograms. The coefficient of kinetic friction is 0.2 between the surface here, and then you need to find the tension and the acceleration for the system. Okay. Now, this is a problem. I'm going to set it up like this, but again, you could have a problem like this, which is actually easier than this. It's the same exact process. You could have a problem where you have one on an incline. You know, you could do all kinds of weird stuff. You could go incline to flat. But again, it's all the same process. So as long as you understand the process, you should be able to apply it to just about anything, okay? So it's not about memorizing, it's about understanding. But again, our process is always, we want to do steps here. So my first step is going to be to draw my free body diagram, which is pretty much always my first step. So let's do this for M1 first. So there is M1, and I know that looks just like that box over there. But if I draw the forces acting on it, I am going to have the force of gravity. I'm going to have my normal force, my force of tension, and then my force of friction going this way. Okay, so that's for M1. If I draw my free body diagram for M2, now again, I'm going to use a different color. I would recommend that you guys do the same. It'll just, help you not get confused as far as what's going on. But for M2, I am going to have FG going down, and then FT going up. Actually, I'm going to make FG bigger because I'm going to assume it is going to accelerate down. All right, so there are my forces. And then, so first step is free body diagram. Second step, as always, is to use your free body diagram and write your equations. So for this one, if I do sum of the forces in the x direction, it's going to be Ft minus Ff equals ma. And if you notice, okay, this m goes with that. That's why I'm making it all one color. So I have my magenta color here, okay? And then for my y, the sum of them in the y is going to be Fn minus Fg, and again, as always, the stuff in the y is going to be equal to 0, okay? So again, that goes with M1. For M2, well, if this one is accelerating to the right, this is really important. Which way does this one have to accelerate? That's right, down. So if this one is accelerating to the right, I have to write this equation to be this. I have to go Fg minus Ft equals ma. If I don't, okay, if I don't write it this way, it's not going to work, because if this accelerates to the right, this has to accelerate down, okay? So you have to make sure that they agree. Remember this, I'll call this even M2, because that's M2, again, but again, that's why I'm using the different colors, and that has to be M1, okay? All right, and then I'm going to plug some stuff in. So for Fg over here, it's going to be 20 times 9.8 minus Ft equals 20 times A, okay? And then here I'm going to get Fn minus 40 times 9.8 equals 0. So my Fn equals, I'll do the math in a minute. And then here I'm going to get Ft minus 0.2 times whatever I get there equals 40 times A. So let me real quick do the math here. This one I'm not going to pause it because I should actually be able to do it on my phone. All right, phone, let's work here. Okay, 20 times 9.8 is going to be 196, I believe. And then, so let me just double check. Yep, 196. So this is going to be 196 minus Ft equals 20A. And then on this one, 196 times 2, because that would be 40, it'd be 392. So this is 392 newtons, 392 times 0.2. And I get Ft minus 78.4 equals 40A. All right. So now I have an equation here, I have an equation here. So I have two equations, two unknowns. I don't really care how you go about solving. You just got to be able to solve it. So do some algebra and solve for FA, or solve for A and FT. I personally like to solve it this way, so I'm just going to bring this equation right down here and go, okay, 196 minus Ft equals 20A. So if you do the math here, my FTs will go away, so bye-bye FT, and I get 196 minus 78.4, so 196, 196 minus 78.4, and I get 117.6, so I get 117.6 equals 60A. So then if you solve that for A, a little bit less than 2, divided by 60, and 1.96. So 1.96 meters per second squared. Now, a couple things I want to mention with this. First, this is positive, okay? That means that when I wrote my equations, I guessed correctly. Now, sometimes you might do a problem where if you guess wrong, this is negative, that's fine, totally okay. But then you have to interpret it. So this, I assume that this one is accelerating to the right and this one is accelerating down. Because this came out positive, it is, okay? If it came out negative, that means it's accelerating the other way, which in this case is kind of weird, but you might have a case where you come up with a negative number, and that's okay, okay? But so I now know A, if I want to solve for Ft, I can take this and plug it into either this equation or this equation and solve for Ft. The sweet thing about these problems, and I know you guys love this because you guys are big on, did I get the answer right? Is you can just plug this into both of them and you should get the same exact number, okay? Because again, Newton's third law, the tension here has to equal the tension there. So, but if I do it real fast, so 1.96, I'm just going to do one of them, but you guys can do both if you want, times 20, okay, and then I need to do 196 minus, I get 39.2, so 196 minus 39.2, and I get my Ft to be 156.8, so Ft equals 156.8 newtons, and again, if you plug it into the other one, you should get the same thing. All right, bye kids!